Do you know about the dynamic programming technique? It's one strategy for the algorithms which allows us to reduce the complexity of a certain algorithm when it's called the second time with the same inputs. So what's the idea of dynamic programming technique? Its purpose is to, once one certain algorithm is called, we calculate its output, store this output in one certain data structure, and when this function is called again with the same inputs, it verifies if it already knows its result. If it's, return the result without having to recalculate the output. That is the dynamic programming technique. But one very important feature that algorithms has before implementing this technique. Algorithms have to be deterministic. It means with the same input values, the output has to be always the same. Algorithms with the same input could produce different outputs. This kind of algorithms cannot be utilized for dynamic programming. In this case, when we have any kind of deterministic algorithm, we can choose to adopt the dynamic programming technique. In this example we have here, we are talking about the factorial function. This function has linear complexity. What it means? It has to loop all elements of the input at least one time. Actually, it's n less 1 because when it's 1 it do not have to process, but it's a linear function anyway. Okay, what you do to transform this linear function in the dynamic programming technique? We have the function itself, that's basically here. We receive one input, we calculate its factorial by reducing the number one value and multiplying in one kind of counter, here our result, and then return that. Here, just this part is already the factorial function. However, we have one part of code before and one part of code later. What they do? Let's first see what we do later. Once we have calculated the output of the function that's stored here in this result variable, we store that in one auxiliary data structure that is this array. It's outside the function because it has to be on memory, available for the next time this function is called again. So when it calculates the value for one certain input, here we make a cache of the input here that's never changed, then it's a constant. So we make this mapping with this input, this will be the output, and it will never change because the function is deterministic. Then it will return the output. But the next time the function is called again with the same input values, what will happen? It verifies. We already have the result stored for this input. Yes, we have. If we have, what will happen? It will not be linear anymore. It will be constant. Time 1, constant. It will just access the value that already is stored in a directly and indexed access and return. So the second time, no loop are going to be necessary. Just a constant output for complexity. And otherwise, no, it's a new input we have never calculated before, then it calculates again normally, and after that save it in the structure. So now let's test that. We have the same here, the same factorial function called twice. One with the 5 input and the second one also with the 5 input. But our auxiliary loop counter, that's just a variable that's being increased every time the code process more than once, that it's what make the complex in the algorithms, it's counting. Then we will be able to see that just the first time it's calculating, it will be linear. However, the second time not. It will be constant. Let's see that. So I want to know the factorial of 5. Okay, let's execute that. Okay. Here we have. Let's just clear this console and run again, then it will be better to us to analyze that. Okay, let's see it. Right, here we have the factorial of 5 is 120 and had a loop counter for why? Because it's linear complex, but n plus 1. Okay, but the second time it also here it also has calculated, but not exactly calculated because it already was calculated before, but we have the same output, but with constant output. So imagine when we are doing that in a long term, the chance for we have inputs already calculated for several different kinds of inputs will be very common. So it is the dynamic programming technique, one of algorithmic strategy to handle the complex of algorithms.